Hello? Is my mic working? Oh good, okay. Is the background music working? We can't hear you, Music is super low, but if it's even on. Okay, I'm gonna... No camera, no music. Okay, let me up the music. No music. There's music. Okay, there's music. Oh, we got music. I don't know if I'm gonna get DMCA strike for this, but I got tired of using the YouTube ones. So I have like a playlist on Spotify of non-copyrighted lo-fi music, lo-fi no copyright for streamers, public playlist just playing in the background. This thing is like over 500 songs. Chat froze. Alright, I almost fixed everything. Let me fix the webcam now. Oh wait, I had stream paused. Ignore what I said. Hold on. Last thing is my webcam. It's been a while, guys. How have you guys been? Oh! I'm back! Haha! Mic volume is peaking. Okay, hold on. I will let you guys know that I am a mic volume is very peaking. Oh my goodness. Okay. Okay. It's no longer peaking. Okay. I thought you were moving out of this room. Yes, Bellum, I have moved out of this room. This is a green screen. Don't know if you can see the background flickering, but like, I'm not in this room anymore. You notice how I'm like higher up than usual? I'm in another bedroom. Let me see if I can show you. Like look. I can like go upside down if I wanted to. But anyways, until I get like my setups finished, I'm just gonna use this as a green screen. I think it's funny. Like I've held like a lot of meetings with it already, and no one has noticed. So I'm gonna like rip up the bandit with you guys right off the bat and say that this is a green screen. Nothing you see here is real. And basically, if I shut off my camera, I'm not even here. Alright. So it's not a clean room. I bet it's dirty. And yes, you would be right. My bed's right behind me, and I haven't been in my bed because I have been so busy for the past 2 weeks. So yeah. My other room, I'm doing renovations on it right now. It is a vertical camera. I'm using NVIDIA Broadcast to be able to switch the cameras on you guys like that. So it's a lot of fun. But yes, I am back. Yeah, I don't have a green screen. It's just whatever GPU thing is running in the background. Anyways, so since I left, the last thing I did on stream was this PCB, I think. Have you slept? I actually slept like 12 hours today. Like, I got the best sleep of my life. Because it was a holiday. And then Bellum said that, somehow he knew I would come back today because it's a holiday. Yeah, because like, I don't have like, well, I have work, but I just avoid it. And I come here instead. So, gotta at least update you guys on what's going on. It's almost the end of the semester. I'm almost back full time. But I like being here. It's just that it's been so busy. I've every single day I come back from school, I feel like dying, and it's getting to me. Like this senior year stuff is getting to me, and I just don't feel like doing this anymore as much. So what we're going to be doing today is we're going to go ahead and make this a little better. I should show you guys what's going on with the RC cars. I am going to release it as something that you can purchase on my store. But in general, what I've been up to for these past 2 weeks is making these things. These are the RC cars. Basically, we had about 15 people in the span of like 8 hours to 10 hours making these cars like be a reality. I ordered those PCBs and they came last Friday at 4 p.m. So literally these PCBs were like, either they would work or either they would not work. And thank goodness they worked. It's an army of cars, basically. You're looking at about $2,000 worth of cars and equipment on your screen right now. And so these PCBs worked first try. Each card individually is about $100, including the controller. And it's just me trying to chop down as much of the cost as possible. But these are relatively inexpensive, I would say, compared to like what else you can buy today. Each of them has an Arduino, an NRF24L01, two L298 motor drivers, some LiPo batteries, and they're pretty slow, but I brought one home with me, so I'd like trick it out. Maybe I'll do that tomorrow or something, I don't know. But like these cards work, and I have my source code on my GitHub. Or on my GitHub right now, there's skeleton code that is just available for like programming this thing. But that's the cars, and then here are the controllers. Here are the 20 controllers that the students are going to use to be able to drive these cars. And they worked first try too. How many RC cars can you buy for 100 USD? One. Well, if you don't count the controller too. And because like each RC car here, I think it's like 50 something dollars, and the controller is like 45. It is colorful, yes. I spent a lot of money on this. I mean, in the store. About two. I calculated the cost. Each one of these cars is around $55, and then each one of these controllers is around $40. So, like, you know, add it up, see what you get. But these controllers are nice, I would say. You have a lot of options for them, a lot of switches, a lot of controls. They are smaller than the original version, the first RF modulator that I made. I will take the purple one, okay, thanks. What is the range? Apparently 1,100 meters if you don't have a wall between you. So 1,100 meters wireless, and about 150 meters if you have like wall or any sort of like barrier in between. This is the antenna, so it's like the range is multiplied. And if you like crank this on high power mode, it can go even further. 2.4 gigahertz wireless transceiver. But yeah. We're having a race on it on December 1st. Last Friday, we actually were trying to have the race then, but like the cars weren't finished. And there was a bug in which it was probably my fault. Basically what happened was I got the PCBs very last minute. It was a Friday. Actually, let me tell the whole story, right? So take you back to last Thursday. Last Thursday, November the 17th, a team and I basically made all the controllers and made all the cars. It was about 15 to 20 people, and we spent like from like 2 p.m. to literally 2 a.m. that single day at school making all of these cars and making all of these controllers. Do the wireless complete with each other? Did you test them all at the same time? Yes, we did. We tested all of these at the same time. They just run at different frequencies and different channels. Basically, what I did was each car has a team number. So let's say this car on the top left corner is team 100. This one on the middle here is 101, and then 102, 103, 104. Basically, the team number is going to be the channel they operate at. So if you run both of them at the same time, channel 103 and like 107, they have different controls. Yeah. Yeah, if it's more than 300 meters, you need a camera to see the cars. So like these are basic. So they're like we went on floor 3 of building 9, and we basically raced around there. And we built a whole racetrack, but like we couldn't race that day because the cars weren't finished. But on Thursday, we spent from 2 p.m. to 2 a.m. a team of about 15 people working on building both the cars and the controllers. Thursday, the PCBs were not here. So it was like really stressful because I didn't know if we would have the PCBs, like this PCB right here to build with, or if we would have to use breadboards. Because I ordered this on like Sunday, and I had calculated that it would be here on time, but there was a customs delay. So I was like, uh-oh, we might have to use breadboards. I got the customs delay message on about Wednesday, and it was like, it's gonna be a day late. I was like, oh no. So on Friday at 4 p.m., the PCBs arrived, and I was like, oh, thank goodness. And so what happened was, almost all the cars were built, and almost all of the controllers were built. Now the problem was, we didn't know if the PCBs functioned or not for the cars. So what we did was, at 4 p.m., and by the way, the event started at about 5 p.m., I think. So at 4 p.m., I got the PCBs. I got everything to build the PCBs on, like, one box, and I shipped it to school as fast as possible. At 4:45 p.m., I basically told my team, okay, here's the PCBs, here are the parts to make the PCBs, here's the schematic, here's the source code, here's everything you need to test on it, good luck. And so at 4:45 p.m., I said that to them, and then I went to go do the lecture part. It was at 5 p.m. And during the lecture, I spent about 1 hour and 30 minutes talking to the students. There were about 80 to 100 students about Arduino, about everything. I was basically stalling for time because while I was teaching, the team of like 15 people were like building the cars, testing them, and seeing like if they could work. And it was like literally 20 PCBs soldered by the team, and most of them like it was like the first time soldering. So like there were some shorts to say the least. So we got everything tested, everything ready, and then someone came up to me and said, okay, after my lecture, they came up to me and said, the PCBs aren't working. I was like, why aren't they working? And they uploaded the source code I provided to them, and by the way, the source code was originally for ArduPot. This is ArduPot right here. I basically used ArduPot in order to give like a prototype model for the RC car, and ArduPot has different pinouts. ArduPot has an OLED, right? And so this OLED wasn't on this RC driver. So what the problem was is that the person I gave this code to went ahead and programmed it with this OLED interface already on it. And since this OLED was on pins, like, the OLED was connected to these two pins right here. And since it was interfaced, basically it, caused problems and one of the motors did not turn. Or it was turning really weirdly. And we were trying to figure out why it was that. We were trying to figure out if it was the PCB or if it was the code. And it turns out it was a code because we haven't removed that OLED initialization, and it was accessing the I2C pins in order to do funny stuff to it. And so we removed that, and that was after Friday, and then this PCB works correctly. So thank goodness I didn't have to redesign this. And it was a software fix. Yeah, I literally after the event we couldn't race because the cars weren't working. After the event, I went ahead and went into the code, deleted those two lines that initialized the OLED, and then it worked perfectly. And it was amazing because this PCB works the first time. There is this minor flaw. There is a minor flaw, and the minor flaw is that it doesn't turn right. It doesn't drift. Basically, I connected all the enable pins to this pin right here because literally everything else was accessed. This is a little bit of a UGV because I have the ultrasonic sensor here and also LED sensors on the bottom here, which I didn't implement. Chris is gonna cry when he sees people racing them and smashing them into each other, watching parts fall off and people not even caring. These cars are not fast. Let me find the video. These cars are not that fast. Basically what happens is that they were really, really slow. So even if we crash them into each other, nothing in general will happen. Alright, I'm gonna download this video and show you guys. But we're still preparing for the big event. Where's the downloaded video? So on the day off, basically, this Tuesday, or 2 days ago, we basically took over the school at night again, and we basically raced them, tested every single car, and got them ready for distribution on Wednesday, which was yesterday. And then yesterday, I went to school and basically tested all the vehicles. And so these two cars are being controlled by separate controllers, and they're not fast. They are very not speedy. So I doubt they'll be able to crash into each other well. They are not speedy. Because the gearbox, the TT motors on there, only accept the 9 volts batteries. And also, I think our batteries were discharged then. So it's a very slow vehicle. Which means, there isn't enough momentum for them to, kill each other. Right? Have you seen Chrome on Steam? It came out November 18th. I have not. Oh! This is very interesting. Oh! I like this. Wait, this is so cool. All right, I'm already sold on this. I'm already sold on this. Let me just keep this in one of my tabs. Breadboard simulator. I don't have to you don't have to build breadboards anymore. Anyways, yeah, the cars run. They're fine. It's got a solo dev. Amazing. I want to make sure they got community support. Yes, that is cool. I want to try it out. I want to try it on here because if it actually works, it's gonna be so useful. Basically, the class I took during the summer doesn't even need to be built on a breadboard anymore. Yeah, and plus, I may use it for like a project I have. Like it's the finals. Like I don't know. Like I have so much to tell you guys from the past 2 weeks that's going on. Basically, it's final season for me, and because I'm an upper graduate student, literally all of my finals are projects, and literally I have not done any of my projects so far. So I'm like slightly dying here, but like. I have a project in order to improve Blinky Learner 2 using a master-slave protocol using JK flip-flops. I have another project for like drone racing I'm doing like tomorrow. I have another project for software engineering that I haven't finished. Like it's just projects galore. Like the only like non-project class I have is communication systems, which I'm like working on, but it's hard. So it's been a tough balancing act, trying to get everything together, but I think it's going all right. So these are the cars. If you want to get one, I should put it on my store at some point. I also have to put Blinky Learner 2. Blinky Learner 2 is in the works, but hopefully sometime soon. Okay, I'm done ranting. Anyways, what I wanted to do today was I wanted to fix this RC driver PCB. Basically, remove the UGV capabilities and add more of the capabilities for like the enable pin and whatnot. Basically, to add 2 PWM inputs and then allow for like the rest of the pins to be used by LEDs or something like that. I don't know. But basically, what we have here is just not possible, it's not great because. If you wanted to have like regulated turning, you can't because all of the enable pins are connected to literally the same pin right here, right? You need split enable pins for the left L290N and the right L290N to be able to drive separately, right? So, it's still a lot of work. I don't think I'll get a break until after finals. Finals for me is the week of December 12th to 16th, and then after that I should be free to go, aka I can stream like for 6 hours again. I have to finish the Banshee UAV. My battery vending machine, I need like a ground station component for that too. Some prototype program have some similarity with Code Arduino simulation. I think Tinkercad has that. Tinkercad has like basic breadboarding, but not as pretty as not as pretty as this one. This is really, really nice. This is really nice. Oh my goodness. This is really nice. Yeah, is this all customizable? Is it like a spy simulation? Yeah, this is really nice. I'm gonna recommend this. You know what? I'm gonna get this, and then I'm gonna go ahead and use it on the stream for like my next project, and I'll let you know if it's cool or if it sucks. But like so far, the images, it looks pretty cool. Wow. Looks pretty awesome. Oh, it has simulated wiring too. Oh my goodness. This was so much easier if I used this during the summer instead of like whatever I did. But yeah, it's awesome. Review on simulator. Yes, I will review the simulator. I would hope it has wiring. Me too. Alright. I also bought a bunch of these knobs. I kind of want them, so I'm not going to return them. But basically, I designed the joysticks and the potentiometer knobs on my controllers. I designed these like the day of. Basically, I came home at 2 a.m. that night, and I did not sleep from Thursday to Friday. I pulled an all-nighter. And basically what happened is I made the CAD for the potentiometers and the joysticks, and then printed all 20 pairs of them in like a day. And I had all my printers running again, and it was like crazy. Like I don't know. I that day I just didn't sleep, and then that weekend I also didn't sleep. And then we're up to now. So I think that's what I have been doing for the past 2 weeks. It's been just a lot of crazy work, and I have a lot of reports to do. I have so many reports to do. I have a crazy amount of reports to do. But anyways, I bought these potentiometer knobs as backup in case what I had didn't work. And I think they're like tiny little guitar knobs. I think they're pretty nice. And I just have a bunch of these now in case I need to use them for anything. And I sure hope these work. You just like press them on, I think. Yeah, no, they work pretty well. Yeah, so I'm just gonna use them for my my macro board because I stole the previous knobs off it. Looks like this one's not staying. Probably gonna have to yoink this out a little bit. Yeah, so it sticks. And I brought this here because, you know, ideally I wanted to go ahead and play some Voltex after this, but I'm not sure if I'll have enough time. I have to go back to writing my reports up at like 10 p.m., so I'm only here for, you know, a brief second. But let me go ahead and make another version of this, basically RC Driver 2, and correct this mistake. Oh, that's my NVIDIA broadcast. And then maybe tomorrow I'll go ahead and review that simulator, because it looks very interesting. How have you guys been doing? Anything interesting happening from whence I last left? I'm gonna save this RC Driver project as here. The British Queen died. I think I was here when that happened. We're trying to get a big project done for work, or else the bank will collapse. That's good. That's good to hear. I don't think that happened within the last 2 weeks, Team KDK. Michael Jackson died? I think that was a while ago as well. You know, I'm no pro at like history, but I think that happened a while ago. Oh, hold on. I have to... Hold on, let me boot up KiCad 6.0. Oh. There we go. The 2009 thing. Oh, the Ottoman Empire collapsed. The Russian dropped a bomb. Poland. Okay, that I think was actually within the last 2 weeks. I saw it on Reddit. That was within the last 2 weeks. I don't want my breaks to get longer and longer, but like, school is hard. I'm not gonna lie to you guys, school is hard, and like, I'm kind of glad it's going to be over within 6 months from now. All right, so what am I looking at here? Basically, I have to reassign the pins within the. Oh, hi, Polybius. We're not running yet. Basically, I have to reroute this pin over here. I have to basically create enable left and enable right for the two headers. Enable left, enable right. And then I have to put, let's still put the ultrasonic sensor, because I think that's a lot of fun. But like, I'm going to get rid of the IR. I'm going to put echo here, I'm going to put trig here. I'm going to put the Infor here. And then I'm going to put controllable LED here. And I think that will be able to suffice. So then this LED will no longer go from VCC, but it'll go from this LED pin. And we can put some controller logic. There we go. Okay. So now I can go ahead and switch this from EN to EN left. That way we get custom steering logic. EN left, EN left, EN right. I also have a few PCBs I have made for like another thing I was part of, but I'm not sure if I'm allowed to stream it because I did hear about an NDA, but like I never signed an NDA, so I don't know what's going on there. This doesn't exist anymore. Okay, Echo Trick's still a thing. So this is enable left, enable right. That's gonna be on D9010. I do keep a box with me. I think. Oh, here it is. I keep a box of Arduinos with me just here, just like to memorize the pinouts. So 9 and 10 should be PWM capable. I think that's it. Oh, and I also need to make some sort of regulator, some sort of safe regulator, or a BEC. So in case they want to go ahead and put like past 9 volts into the system here, I need to like take it from here, this raw input, and they need to slap on a circuit that will regulate it from like a 4S level battery down to whatever small voltage it has. So we don't need no sticking NDA. I don't know, like I've been hearing on campus there was like a NASA project that wanted me to help them and stuff, but like I had to sign an NDA to be able to participate in it. As long as it's something you own or allowed to stream. Yeah. So if I didn't sign an NDA, I can stream it. Definitely. Okay, hold on. I have a filter. I need an LM317. Well, 7805 would work too, right? Let's go down here. Yeah, give me a regulator circuit. So this regulator should be able to stop large amount of voltages. Well, unless there's more than 1 amp, but like nothing in here actually draws more than 1 amps. It's just the external part of it. Hi, Kiaru! Happy Thanksgiving! Happy Thanksgiving to you too. Welcome. I almost forgot you were the one of the founders of this channel. Chris eats solder paste for Thanksgiving. I haven't soldered for a while. Well, I did it last Thursday, but you know. Not a thing here. Yeah, I work on Thanksgiving. I don't know if you can count this as work, though. I'll count it as work. So this should be raw. So raw would go into here, and this would be 5 volts. Well, I can probably use the 5 volt power pin. $5 volts. Yeah, because that regulates down to 5 volts. No, I want a 220. So like a big format IC chips. Bro, the green screen, nice. I talked to Stream about it. Basically, I moved rooms, so I'm no longer in my old room. It's not a green screen, but it's like a virtual camera. It's NVIDIA broadcast. So I want this thing to be able to be soldered by like other people. So I'm just gonna put a big format chip. There's always some work at holidays like caretakers. Yes. I don't know. This is like one of those days where I can finally stream again because I don't have like work overload. But I think starting maybe like next week, I'll be back on the grind. Alright, so 5 volts goes in there. because I want to attach a forest level battery in order to drive the motors, and basically what we're gonna have here is oh, okay, I have to change this VN to from VN to raw. So then that'll just go get the full 12 volts or whatever from it. And then the 4001, I might have to change that to a maybe a PMOS or volt. Maybe I'll do the PMOS circuit. I know. I think it was Polybius or Team KDK specified something along the lines of a PMOS. I have the thing here. I think, yeah. This circuit. So maybe I regulate it even further. So if I remember correctly, it'll be in this format, and then you get the raw input there. You just connect it straight to ground. Yeah, basically what you're doing with this circuit is you're preventing reverse polarity from happening. I don't know if you need any extra components to this. You know what? Screw it. I'm gonna open a new project. I did build a circuit with this. Just put it on another screen. Okay, yeah. I did build another circuit with this. This one right here. Because I do think it is needed. I'm just gonna copy paste that. And drag it up here. So this goes from raw to VN. That means I have to change this to VN. I don't want the voltage drop of the diode to be able to affect my circuit. So I will just go ahead and use this instead. Was that the first time I said it, but I also said it. Okay. I was starting to worry I wouldn't get to spend these points. I don't know if I'll be able to do exercise here. There's like not a lot of space. Maybe I'll think of something.
It's an appropriation of speech. There's no excuse for that. That never has happened once in the history
All right.
of common law.
Let's see.
Who's going to define it? I know the answer to that. The last people in the world you would want to. And then
What's with like words and lo-fi music? Interesting. Alright, so this is going to be the circuit for that. Raw goes in here. You have a PMOS, you have the capacitor, you have the resistor, the capacitor. This diode will have to be, I think this is good. This is for a forest level battery, so this will be like a 20 volt limit. Okay. Let's just put this here. Once I helped Lil in 2017 thinking that the P-channel MOSFET on the Raspberry Pi was a regulator, so he put like a 9 volt on the R Pi. Uh-oh. That's not good. Did it get fried? Okay, I don't need this diode anymore. Power switch. He did not say, but I warned him it was not working as a regulator. Uh-oh. Well, that's definitely not good. Motor external power. These two. Motor output. You know, in theory, you don't even need the earth, ground, and VCC pins here, because it's just common grounded via the motor external power input, theoretically. But I'll leave it there just in case people want like something else. This would be the ultrasonic sensor input. Theoretically, yeah. Okay, I'll get rid of this because I don't need any more. And let me go ahead and put everything here. But as I say, if they don't want to listen to me, they have to get their own experience. I mean, you get your own experience from like failing, so. You will see something explode again, you don't want to see the thing explode again ever. Failure. You learn from failure. You learn from failure. That's what being an engineer is like. Let's put all the regulator circuits up here. Why is this text so long? Alright, how does that look? So reverse polarity circuit, voltage regulator, 3.3 voltage regulator, external power. I don't know, do you think it'd be better to have a TO-220 or like a SMD component instead? Because it still like draw the same amount of current, right? Depends on how big it is, really. Let's see. They only have the TO-220 footprint though. Heat. Yeah. I guess heat's a big thing. But it's putting 5 volts into the Arduino. Like it already has a. It's not drawing that much current. I'll keep it as a package. All right. Anything else I miss? So 5 volt voltage regulator, 3.3 voltage regulator, reverse polarity protection, external power, header pins, ultrasonic sensor. External power has VN going into it. Okay. Okay. Looks fine. Looks generally okay. Let me go ahead and assign all the footprints. He said he was not allowed to use electric drills, but maybe it was because what his mom was said. That's fun. Oh, all my stuff is assigned. Good. Okay. I mean, my parents wouldn't let me use electric drills either. I don't know if it's for my own sake or not, but, you know. Alright. Is there a button on KiCad that says unroute everything? Because I might have to, like, use that button, like, real quick. He was 14-15, now that makes sense. My dad insisted I play in the street. Is there a button that says delete all tracks? I wonder. Or is that just like... Is that literally just, hold on. Okay, hold on. We'll do Control B first to get rid of those. Alright, Google. Google it is. U. Oh. Well, that's useful. So either I delete all the tracks like that. Is there grouped tracks? Selection filter, all tracks. Oh, is a selection filter. Oh, I found it. Found out the Vias too. Let me delete those too. Okay. Alright, now I don't need this. Oops. Oh, hold on. All items. I need this. Don't need this. Don't need this. Oh. Enable left. Right. Okay. Now, it's really going to be a question as to how I put these things on, because they are quite large. Maybe like one over here. Okay. Diode goes with this thing. Oh, that's a really big diode. Well, I guess it's like 20. It's like freaking 20 amps, so I guess. Like that. And that'll work. Okay, and then just the capacitors now. So, okay. You know, I didn't have to delete all those tracks. I just realized. Hold on. I can fix this, I can fix this. I did not have to delete all those tracks. Okay, okay. Okay. I just need to delete this one. Basically, this one. Oops. This one, and then the track associated with it. You, right? Yeah. And then delete this one. Wait. Oh. Wait. Okay. You can delete this one. Oh. Okay. And then I can just hide these. Okay. And then slap these up down. Okay, and I can do the down in the resistor over here, on the left. Is this a via? Oh, that's not good. I need to make room for these two components later. Okay. Put this over here. So C9. C9, C8, C10, C11. It's an interesting configuration, but okay. And then C6, C7 will go over here. Yeah, I think that's pretty good. Okay, and then I just have to figure out exactly what's going on the other side. I'm pretty sure, like, if I open this, it's gonna be a huge mess. It is a huge mess. Okay. Okay. Alright, time to fix some things up. I'm gonna do the, before I wrap this entire mess, I'm gonna go ahead and rename these things. Hmm. Yeah, I can't put it on the side, so I'll just put it there. This is the... I think I should put it here. What's this size? 0.0.3, 0.3. Okay, so for an FQP, let's see. I think I'm going to rename this as a 27P because those are easier to come by. Data sheet. Gate drain source, okay.
Incredible. Like, sonically, literally everything, man. It was just, wow. You know what I mean? It made us look at ourselves like, what the fuck is we doing? You know what I mean? This is a masterpiece. This kid just made. We with him damn near every day. We outside, you know what I'm saying?
Even smaller. There we go. Alright. I think that's all the labels. I do have to change this one though. So I'm just gonna delete this text. Alright, I think everything's labeled as much as possible. Maybe I'll add a plus here. Alright. Now I have to like fix this routing. And 4L. Okay. Okay, what do we got? Echo, trig, right, these are going to be different now. Okay. LED has to go all the way up there now. Enable left has to be, okay, so this is going to be changed. This one can cut off, okay. Enable left, wow, this is thick trace. Enable left. Maybe I can do... that's an issue. We can go through here. Yeah, so this is wrong too in 4L. Go there. Okay, so just a big 360 around that. All right. What's next? Alright, and then this would be VCC has to go there. What is this connection? Oh, that's just... Oh, okay. That's just VCC. Alright, LED I have to go from here, basically. Okay, so I'll start from red. And then I'll go to green. We'll go to red. Okay, that one's good. It's all covered. Alright, do we know Pro Micro? The R's there. The R's there. I didn't mess up this time. The R is there. That'll these two things together. Okay, so then I have to go ahead and wire this up. So there will be a lot of current going through this. Oh, Lord, okay. Okay, this is gotta be... I'm gonna delete this for now. This has gotta be much, much closer. And a much smaller trace. This one, okay. Alright, so that we can go ahead and do this. Basically better power regulation. Well, theoretically there's not going to be a lot of current going through this one, so just do that. And then on here, green. Okay, right side's done, left side. So we first have a lot of feet going through here. What is this? This is reverse polarity. Right, okay. Oh, we changed the diode. There's no diode here anymore, right? Okay. So this diode does no longer exist. Okay, I have to reroute this one then. Wait, I can just keep that there. And then basically reroute this. Down here. Go. Okay, and then I can just do raw from here to here. All right, regulate this. I find that like this circuit ones are usually the easiest to. Oh, okay, what kind of mess is going on here? Oh my goodness. Okay, so this is in one left. You kind of have to like move this a little more to the left, right? Okay, so move that one to the left first. This is, why are they both in 2L? Oh. In 1L. I always try to auto route first to watch it fail. There's no auto route in KiCad though. As much as I would like to watch it fail, I don't think I can. try to move the actual component down a little bit. Well, there's ways. Using netlist files and stuff with external programs. I mean, the real question is, do I want to go through that much effort to see a machine fail? Probably not. That's too large. What time is it? Oh, it's 10:19. Oh, 1 hour goes by so fast these days. Time flies. I wonder if there's still a way for me to put a diode there in the middle. Probably not, right? This looks suspicious. I would love to use that empty space. It's too big. Maybe the resistor though? Maybe. I don't know why they've lost its like pin assignments though. There we go. Both vertical and horizontal alignment done. I have to deal with this thing. Kai crashed all the time on me. I think he's fritzing or something. Oh, fritzing. I remember like trying to get a free version of that software. Don't you have to like pay or something for that? Okay, I can get there. I can get there. Oh. Okay, yeah, that was easier than I thought. Now I fix this wire. I bet that breadboard simulator blows fritzing out of the water though. Yeah, I think. Fritzing started out free, but then had a pro version for money. Yeah, I was like, when I first started doing electronics, I was like, huh, I should probably get one of these like simulator programs. That would really help me a lot. And like fritzing was one of them. But like, I couldn't find a way to get. I did have a free version. I think I did have a free version. But like, it was like, it wasn't that great. I think it was like between multisim and fritzing, a multisim one. What is this wire? In 4L? Oh. Let me just get rid of this fire then. Okay, and I need to connect these ones. Okay. Oh, these V and these need to be connected together. Let me just go around this mounting hole. Oh, and that capacitor needs a raw too. Let's review it tomorrow. On stream. Unfiltered. Let's see capacitors. I think a thin trace is fine. Wait, this goes to raw. Oh, this one didn't change. Raw. This one's also raw. Okay, anything else? Wait, did it really get everything? Oh no, I didn't get everything. It's saying this VCC is not connected. This is not a VCC, that's an LED. Okay. So then this just needs to be connected to VCC over there. Oh, right, because the green one's Earth, and then the red one is... Yeah, this left portion does not have a VCC. A lot of it's covered already. So, okay, let's draw a trace. This portion of it needs VCC. Okay. Like right here or something. Duplicate it. All right. Boom. Done. So now we got rid of the light sensors and added some power circuitry, and this should be okay unless we feed it too much power and then it'll kind of blow up. Okay. What does it look like? Doesn't look too bad. Just a little more capacitors and whatnot. Looks fun. Alright, I think that's it for me today. An hour and 30 minutes of some PCB design. I'm gonna go ahead and order another one of these. I gotta change the text to V2 now. See, driver. There we go. V2. GG's. GG's, everyone. Alright. Let's see who's online so we can rate them. Oh, look who's online. Oh, it was... Hold on, it was loading. Alright, let's go to Kenshi. Thanks for watching, guys. I'll go ahead and download that Crumb simulator and we can go ahead and do my project on it tomorrow. My project is improving on Blinky Learner, so we're gonna, you know, make some improvements to Blinky Learner using the master-slave flip-flop protocol, and then that'll be it. That'll be it for that stream. But yeah, thank you so much for watching today. Hope you guys enjoyed. Have a great rest of it. Blah, can't speak. Have a great rest of your night, and I'll see you tomorrow. Bye bye. Flip, 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 flop.